This is a more difficult quadratic that we need to factorise. It's a quadratic because the highest power of, in this case, the variable is n. The highest power is the power of 2. If we look at each of the terms, we've got a 40n, we've got a 24, and we've got a 6n squared, and we can see that straight away that 2 will go into each of those. That's the highest. There's nothing bigger than 2 that'll go evenly into each of those. So that's what's called a common factor. And that's your first step always with these. Look for a common factor. And in this case, the common factor is 2. So we can say that 40n minus 24 minus 6n squared equals 2. And then we say, what have we got to multiply 2 by to get this first term? It will be 20n. What have we got to multiply 2 by to get negative 24? Well, that'll be negative 12. What have we got to multiply 2 by to get negative 6n squared? Well, that'll be negative 3n squared. We've now got 2 factors, but we can factorise this one even further by using the cross method. So the one in brackets here, we're going to use the cross method. Now, before we do that, we probably should rearrange this and get the highest power first, so minus 3n squared plus 20n minus 12. We do our cross method, and we know that the 2 factors that go on the left-hand side are going to multiply together, give you negative 3n squared. Now, that could be either negative 3n times n or 3n times negative n. So let's just start with negative 3n and n. They multiply together, give you negative 3n squared. Now 12, well, I've picked myself a hard one here because 12's got lots of factors and it's negative 12. So I could have negative 12 times 1, and then I could have the negative on the other side, so it would be 12 times negative 1. And then we got negative 4 times 3, or 4 times negative 3. And then I've got 6 times, or negative 6 times 2, or 2 times, or 6 times negative 2. So we need a strategy as to which one of those, because that gives us 2 combinations here and 6 combinations there. So we've got lots of different ones we could try. So we know we've got a positive and negative here, and we want to end up, when we add the 2 together, to get a plus 20n. If we want a plus 20, it means that if these are going to be a positive and a negative, it might mean we put the negative down there and the positive up there. Maybe. Not always, but maybe. So that's a good starting point. And we want to see how we're going to get positive 20. Well, if I do 12 and 1, it doesn't matter where I put the 1, the 12 there, and multiply them there, I'm not going to get anywhere close to 20. If I put the 4 and 3, if I put the, say, 4 down there and the 3 up there, that's not going to get me close to 20 when I multiply and add. So I'm going to put the negative 6 down there and the plus 2. Try it. If it doesn't work, I might have to put the 2 there and the 6 up there and see how that goes. So it doesn't matter which one you multiply along first. I'll multiply along this one first. So negative 3n times negative 6 is plus 20n. And then multiply along that way, and I get plus 2n. And bingo, looks like negative 3 times negative 6. That's not equal to 20. Negative 3n times negative 6 is plus 18n. I was begging the answer, wasn't I? I was just trying to get to the 22 quickly. So negative 3n times negative 6 is plus 18, and then n times 2 is 2n. I always add those 2 together, and I get 20n. Now I've got my 20n, which is correct, which is the middle term. A bracket around here, and a bracket around here. If I didn't get plus 20n, I'd have to try swapping those, and then if I still didn't get them by swapping everything here, I could go back and do the reverse and put the positive 3n there and a negative n there. So sometimes you've got to go through a number of combinations before you get to the right one. Okay, so this is 2. Now this has been factorised to negative 3n plus 2 and n minus 6. So we've got 3 factors which multiply together to give us 40n minus 24 minus 6n squared. If you would like to do a check, we can multiply these 3 out, and so this is just a way of checking your answer is correct. Now that 2 is distributed over one of these brackets. Don't put it multiplied 2 times that and then 2 times that. That's not what it works. If you got 2 times 3 times 4, you don't multiply 2 times 3 and 2 times 4. You multiply 2 times 3 and then you multiply that answer by 4. So we'll multiply 2 times the first bracket and we get negative 6n plus 4 by multiplying 2 times the first bracket, and then we've got n minus 6. Now we can use FOIL, and we do first negative 6n squared outer is plus 6 sixes are 36n inner plus 4n last minus 24. Negative 6n squared, collect like terms, 36n plus 4n is plus 40n, and then minus 24. Now that is the same as the question that was asked up there, so we know our answer is correct. So there's my answer, factorised. In this case we've got 3 factors. There are some special ones that you should be aware of, and that is the difference of 2 squares. So if you've got a squared minus b squared, now that's quadratic in a and b. You've got a squared and b squared. There is no using cross method there. All we need to do is to recognize this pattern and remember it. It is a minus b times a plus b. Now that's one that needs to be committed to the memory bank, and recognize that. I will abbreviate difference of 2 squares as dots. So when I talk about dots, that stands for difference of 2 squares. Let's do an example of factorizing. So factorize, and if we had 8x squared minus 2, we want to factorize that. At the moment you look at it and you say, well, if there was what we could call a trinomial, 3 terms in the expression, we could use the cross method, but here it is a quadratic. First rule with factorization, always look for a common factor. What are factors of 8x squared and 2? Well, the answer is 2. So that's 2, open bracket. What have I got to multiply 2 by to get 8x squared? 4x squared minus 1. And then they say, well, hold on, what's that going to do? The only one you know with 2 is dots, difference of 2 squares. So what we can do is write these as its difference. There's no sum of 2 squares, it's only the difference of 2 squares. So we can write it as something squared minus something squared. What have you got to square to get 4x squared? 2x. What have you got to square to get 1? So that's exactly the same. I've just written it in a different form. 2x all squared minus 1 all squared is the same as 4x squared minus 1. Okay, now I've got it in the form of a squared minus b squared. So it fits our pattern. and we can go 2. So this is my A, if you like, and that is my B. And the factors of a squared minus b squared is a minus b, so that'll be 2x minus 1 times 2x plus 1. Okay, so difference of two squares, well and truly worth remembering. Always look for a common factor first. And then in this case we use difference of two squares. In the one above we used our cross method to factorise.